Hey everyone, long time no see, right? I know I haven't made videos in a while, but I have been real busy lately. Anyhow, here I am, and today we're gonna talk about limits because before you even think of studying derivatives or integrals, it is important for you to understand at least the basic concept behind limits. So let's start. Assume we have a function f of x. We say that the limit of this function as x approaches a number c is equal to the output value the function approaches as the input x gets closer and closer to c. To understand this, I think it's better to see an example. Take f of x equal to x plus 41. You can easily see that for x equals 1, f of x equals 42. So we can intuitively assert that the limit of f of x as x approaches 1 is equal to 42, right? To verify that, we can plug in values that are very close to 1. For example, if we approach x equals 1 from the left, we have
For x equal to 0.9, f of x is equal to 41.9. For an x equal to 0.99, f of x is 41.99. And if we skip ahead, you can see that for an x equal to 0.9999999, we have an f of x equal to 41.999999. And this goes on infinitely in such a way that it's easy to realize that the closer the x value is to 1 from the left hand side, then the f of x gets closer and closer to 42.
Similarly, if I approach 1 from the right hand side, that is, if I plug in for instance 1.1, then f of x equals 42.1. Same way, if I plug in 1.001, I get an f of x equal to 42.001. You see, the more I get closer and closer to 1 from the right hand side, also the f of x will approach 42. Okay? So in the example I just gave you, either if I approach 1 from the left hand side or the right hand side, the output value tends to be the same number. It converges to 42. So we say that the general limit of the function f of x as x approaches 1 is equal to 42. The general limit exists, but that's not always the case because there are some functions, especially when they are discontinuous, that when you approach a certain number x from the left, the output value tends to be a certain number. However, when you approach from the right hand side, the same number, the output value tends to go to another number. Therefore, we say in this situation that the general limit does not exist. So you have to be careful. For a general limit to exist at a point C, three conditions must be met. The first one is that the limit from the left-hand side must exist. The second one states that the limit from the right-hand side must also exist.
And finally, the third condition states that for a limit to exist at a point C, both the limits from the left-hand side and the one from the right-hand side must be equal to the same number. To visualize this in a concrete example, take a look at the graph of this piecewise defined function. By the way, a piecewise defined function is just a function that needs different formulas to be defined in different parts of its domain. Here, our f of x is equal to x if our input value is less than or equal to 1, and it's defined as negative x plus 3 if our input value is greater than 1. As you can see, there's a discontinuity on x equals 1. Notice that the function is defined in x equals 1, but there is an interesting behavior around this point. As you can easily see in its graph, the limit of f of x as x approaches 1 from the left is equal to 1. However, the limit as x approaches 1 from the right is equal to 2. Therefore, the general limit as x approaches 1 does not exist. And this happens because even though the one-sided limits existed, they were equal to different numbers.
It is important to notice that the function does not need to be defined at the point cf of c for the limit to exist, because the very definition of limit states that we are studying the behavior of the function as the independent variable approaches a certain input value, but we are not using that exact value. It is also important to point out another condition for a limit to exist, and it's that the limit must converge to a number.
To understand what I just said, take a good look at this graph. It is the representation of the function f of x equals 1 over x. Notice that it has a peculiar behavior around the origin, and that x equals 0 is not part of the domain of this function, because if we were to replace x by 0, we would be left with 1 divided by 0, and there is no such thing as a division by 0. Let's take a look at this first table of values for when I approach x to 0 from the negative side. So for x equal to negative 0.1, we have an f of x equal to negative 10. If we have x equal to negative 0.001, our f of x is equal to negative 1000. If our x is equal to negative 0.000001, our f of x is equal to negative 1 million. So I think you notice that when I approach x from the negative side, f of x tends to get lower and lower values, which will ultimately lead to negative infinity. On the other hand, if we approach 0 from the positive side, we have for x equal to 0.1, our f of x is equal to 10. For x equal to 0.001, our f of x is equal to positive 1000. For x equal to 0.000001, our f of x is positive 1 million. Now, f of x tends to become higher and higher as x gets closer and closer to 0 from the positive side. So it actually tends to go to positive infinity. Therefore, strictly speaking, there is no limit as x approaches 0 from the left nor the right-hand side, because it doesn't approach a fixed value. And as a consequence, since the one-sided limits don't converge to a same fixed value, there is no general limit as x approaches 0. It simply doesn't exist.
So this is it for now, guys. I hope you have enjoyed the video. I really do, because I have put a lot of effort into this. Take care, and hopefully I'll see you in the following videos. Bye!